Assalamualaikum warahmatullahi ta'ala wabarakatuh. So this is a complimentary video for the video on classification of signals part 2. So in this video I will show you the solution to some of problem example that I give in the video on classification of signal. So the first one shown here is that you are asked to find the total energy of x of t that is equal to 3 tri t over 4. So this tri means triangular signal. Okay. So you can solve this. Okay, let's say we use the equation for total energy, which is E equals to minus infinity to infinity of 3 tri t over 4 bracket square dt. Okay, so this 3 here is simply a constant, so we can take it out. So we can rewrite as and to the power of 2, so it will be 9 minus infinity to infinity. Then we are left with tri t over 4 square dt. Now when we arrive here, what we can do is we can replace this inner part here with the definition of triangular signal. Okay, so let's have a look first at the basic shape of triangular signal. Okay, so for this one, because you have t over 4, so you will have a triangular signal that shapes like this. Okay, it goes from minus 4 to 4, go up and down. Okay, and the rest is 0. Okay, the signal will look like this. And then if you write the equation that define these signals, you will see that tri t over 4 is equals to 1 plus 4 when t is between minus 4 and 0. Sorry, this is t over 4. And 1 minus t over 4 when t is between 0 and 4, and it will be 0 elsewhere. Okay, so you can replace this the inner part here with the definition of the signal. So let's say I take this, okay, to be replaced. Okay, so you have E equals to 9. Okay, the time range is from 0 to 4, and it will be 1 minus t over 4 square dt. Okay, However, before we proceed, okay, I want you to have a look. Okay, this part 0 to 4 only cover this area of the signal, which means it's only cover half of the signal. What about this area? Okay, so this area is not included in our integration here. Okay, so if you look at the signal here, okay, you will see that this part and this part are actually the mirror image of each other. So this is an even signal. Okay, so in that case, we can do the integration using only half part of the signal, but then over here, okay, the whole thing you have to multiply by 2. Okay, to cover for this part over here, okay, that we did not include in our integration. Okay, so since you multiply by 2, then this will become 18, 0 to 4, and if you solve the one inside the bracket there, you will get 1 minus t over 2 plus t squared over 16 dt. Okay, now you have to now you can integrate. Okay, so you will get E equals to 18. If you integrate this, you will get t minus t squared over 4 plus t cubed over 48, and the integration is from 0 to 4. Okay, now if you solve this, I think you know how to solve this. Okay, otherwise you have to revise back your mathematics. You will get energy equals to 24. Okay, now let's have a look at the second question. Okay, so the second question asks you to calculate the average power of x of t that is equals to minus 3t that has time period of 10. Okay, and the time period, okay, the one period range from t minus 5 to 5. Okay, so average power, let's first write the equation for average power. It will be P equals to 1 over t integration from minus t over 2 to t over 2 x of t square dt, right? So this t here simply means t naught. Okay, so now you can replace to p equals to 1 over 10. Similarly, this one simply means t naught, here also means t naught, so you can replace with minus 10 over 2 is 5, and then here is positive 5 to minus 3t square dt. right? So now you can simplify. Here you have a constant. Okay, so you can take it out, and if you square that, you will get 9. So you will have 9 over 10, 5 minus 5. Here you will have t square dt. Now you you can integrate. We'll get p equals to 9 over 10. Then it will be t cubed over 3, from minus 5 to 5. If I continue here, five over 3 minus 5 cubed over 3. So you will get the power equals to